True. So pop quiz 15, which was related to space physics MCQs. In first question, which row in the table correctly lists a galaxy, a planet, and a star? Like example of a galaxy, example of a planet, example of a star. So when we check option A, when we check the first option, a galaxy Milky Way, okay, that's right. A planet Mars is there, that's also right. But moon is not a star. The moon is a natural satellite. It's not a star, but not a star. So that's wrong. When we check option B, a Milky Way is a galaxy, Earth is a planet, and the Sun is a star. So that's why B is the right answer. So for the first one, B is the right answer. Moving on to the next question. The orbit around the Sun of a comet is not circular. The distance between the Sun and the comet varies, as you can see in the diagram. What actually happened, the total energy is conserved. The total energy is a sum of kinetic plus potential. The total energy of any comet or a planet is equal to the sum of potential plus kinetic. So if it is closer, the potential energy will be lower, the kinetic energy will be higher. If it is further, the potential will be higher and the kinetic will be lower. So where in the orbit its speed of a comet is greatest and where it is smallest. So basically we have to find which place it will have the highest kinetic energy, the region where it will have the highest kinetic energy, that region it will have the maximum speed, and where it will have lower kinetic energy, that point it will have the smaller speed. So when we check the distance, like R is the shortest distance and P is the longest distance. Q is there, but it is like moderate between R and C. That's why it cannot be maximum or minimum. So at this point, because it is closer to the sun, the total energy is conserved, the potential energy is minimum. So if the potential energy is minimum, because potential energy depends on the distance between the two objects, like mgh, gp, or gravitational potential energy. So the total energy is conserved. So if the potential is lower, the kinetic energy will be maximum. So at this point, if the kinetic energy maximum, so at this point, the speed should be maximum or the greatest speed. But when it is far from the sun, the GPE or the gravitational potential energy is maximum because the distance is more. So the kinetic energy should be minimum. So at point P, the speed will be minimum. So at point R, the greatest speed is R and the smallest speed is at P. So it matches with option D is the right answer. Is it clear, this one?
Clear, sir.
Moving on to the next question, question 3. In question 3, the orbit around the sun for a particular asteroid or a dwarf planet is not circular. As you can see here, the distance between the sun and the asteroid varies as shown in the diagram. The asteroid possesses both GPE, the gravitational potential energy, and the kinetic energy. Which energy take place when an asteroid moves from X to Y and then from Y to Z? So, like which form of energy is increasing and which one is decreasing? So first, because it is at like at this point, it will be GP and kinetic energy. The GP is minimum here. Why like GP is minimum? And we want the point X to Y, like moving from X to Y and then Y to Z. So when you check point X, So GP is maximum here and the KE is minimum. The kinetic energy is minimum. As it is moving towards Y, so the distance is decreasing. If the distance from the sun is decreasing, it means the GP is decreasing, the gravitational potential energy is decreasing, and kinetic energy is increasing. So K is increasing. So what is the energy change here? Moving from X to Y, and then from Y to Z, the same thing, because the height is decreasing and the kinetic energy increase. So simple idea, moving from X to Y, the GP will change into KE. And same thing at Y also it will have GPE, and that GPE will further change into KE. So what is the energy change? Because the height is decreasing and the speed is increasing. So gravitational potential energy to kinetic energy moving from X to Y, and then again from Y to Z, because at Y it is far from the sun as compared to Z, it is closer. So again the gravitational potential energy decreases and the kinetic energy increases. That's why option A is the right answer. If opposite was happening, like there was the same question and they say that it is moving from Z to Y and then Y to X. So now what happened, because the gravitational potential energy is minimum here and the kinetic energy is maximum. But when it moves in this region, the gravitational potential energy increases and kinetic decreases. So kinetic is changing into potential. Opposite will happen. In question 4, we have two dwarf planets are there, like asteroids are there, and the orbit are approximately circular orbit is there. The sun gravitational field strength is weaker on like it is stronger on Vesta compared to Ceres. For example, if this is representing a sun, so means which one is closer? As you can see this statement. So if you read this statement, the gravitational field strength at the orbit of a Ceres is weaker than on Vesta. So means like Vesta is closer. So Vesta is closer to the sun, it will experience stronger gravity as compared to a Ceres. How does the orbital speed and the orbital time compare with the orbital speed of Vesta? So as we know, those planets which are closer, because as they're closer, they will have a small, and they've already mentioned the orbit is circular, like orbit of the Vesta and the orbit of the Ceres, both are circular. So those planets or those objects which are closer to the sun, they will experience, like when we talk about the GP, the gravitational potential energy, so the distance is less, so it will have a smaller GP, so it will have a higher KE. So Vista will move faster. And when we compare like GP for this one, it will have a higher GP because further from the sun, so the kinetic energy will be minimum. So means those objects which are far from the sun are moving slower and they will take longer time. As compared to the objects which are closer to the sun, they are moving faster and they will take a shorter orbital. So when we talk about the orbital speed of a Ceres, when we compare with the Vista, so it should be smaller. Like this will move slower and this is moving faster, the closer one. So orbital speed should be slower compared to that of Vesta. And orbital time, because it is moving slower and it is far from the sun, and it has a like greater circumference for the orbit. So the orbital time period will also be longer, or you can also say greater. So orbital speed should be smaller and the orbital time period will be greater than Vesta. Like it will take more time to complete its one orbit as compared to that of Vesta. And it will move slower as compared to that of Vesta. So idea is that those objects which are closer to the sun are moving much faster and they have a shorter orbital time as compared to the objects which are far from the sun. This is clear. Question 4. Anyone having a doubt or a question in this?
Clear, sir.
B is the right answer. In question 5, the sun emits energy in the form of electromagnetic radiation. Electromagnetic radiation can travel through vacuum. Which three components of electromagnetic spectrum account for almost all this energy? Like what form of what are the forms the energy sun is emitting out? Sun is giving us the heat radiation, which we call infrared or IR. Sun is also giving us the light visible, which the part of a spectrum which we can see. And sun is also giving us ultraviolet UV, which is most of the UV is blocked by the ozone layer. So infrared is there, the heat radiation, the ultraviolet is there, and the visible. So C is the right answer. In question 6, when in a life cycle of a star, heavy elements are produced. Usually heavy elements are produced when we talk about the high mass stars. So when a cloud containing hydrogen collapse. So when a cloud containing hydrogen will collapse, it will form helium. That will not be a heavy element. When a protostar becomes a stable, so when a protostar is changing into stable star, it's like hydrogen fusion is there mainly, and hydrogen is turning into helium. When a red supergiant explodes, that is like a massive star when they explode. So it start helium fusion and it release a heavy element such as carbon is there, nitrogen is there, and other heavy element. So this part, when a white dwarf is formed, so once a white dwarf is formed, it's like star will eventually turn into a black dwarf and it will cool down. When it turn into a white dwarf, there's no like further fusion happening. So C is the right answer. That a high mass star, like a 4 times or 8 times, like usually 8 times the mass of a sun. And when these type of a star will undergo a cycle, they will first turn into a protostar, then a main sequence with a shorter lifespan, then turn into a red supergiant, then supernova, and it might be like black hole and a neutron star. In question 7, statement J, K, L, and M describe different stages in the cycle of a small star. What is the order first to the last in which the star occur? Like what is the order of this? If we check, a cloud containing hydrogen collapse due to a gravitational field strength. So that is what happened actually. So that is one. A red giant is produced. No, then it should be like a main sequence star. A white dwarf is produced. No, hydrogen undergo a nuclear fusion to produce helium, means it turned into a main sequence. So this is like a protostar and then turn into main sequence. Then from main sequence, what will happen? A red giant will be there. So that will be the third. And the fourth, a white dwarf is produced. That's a fourth. And then it will be a black dwarf. So what should be the order? First should be J. Then we will have M. Then we will have K and then L. J, M, K, L. J, M, K, L. So that match with option A. Is it clear, this one?
Yes, sir, clear.
Okay, the last question from this quiz, which was related to Big Bang. What provide evidence for the Big Bang theory? Like what is the evidence of a Big Bang theory? The expulsion of heavy element into space during a supernova. That is not related to Big Bang, that is related to the star cycle. The increase in observed wavelength of radiation emitted from distant galaxies. Like those galaxies which are far from us, When we observe those galaxies, we observe that the wave, like this galaxy might emit out a wavelength, say example 590 nanometer. But when we receive that radiation, it appears that it is not 590, it might be 594. So the wavelength which is emitted out and the wavelength which we receive or observe, that appear to be different. This is called a red shift, and red shift is an evidence that this is moving away from the us, and like it is going away from us. That's why the observed frequency will be higher than what is actual. Actual is this one. This is what is emitted out. But when it is coming to us, it appears that it appear to be longer, or like an apparent change is there. It appears that it is longer, which shows that this star is moving away or a galaxy is moving away. And if a galaxies are moving away, this is also an evidence that the universe is expanding. But if the galaxy, like most of the distant galaxies are giving us a red shift. If some galaxies are moving towards us, so they will give a blue shift. But that is rare, like few as compared to the number which are for a red shift. Red shift, most of the galaxies are giving us a red shift. So this Doppler shift or a red shift and the cosmic microwave background radiations are evidence of a Big Bang. Like it all start with bang and then everything explode and moving away from each other. Nuclear fusion. So B is the right answer, but what about statement C? Nuclear fusion reaction that take place at the center of a stable star. So again, that is related to a star cycle. Smaller orbital speed of a planet that are further from the sun. That is related to the gravitational field strength, like or a formation of the solar system, but not explaining the idea of the Big Bang. This is correct, but not explaining the idea of the Big Bang. So this was the pop quiz, which was related to space physics questions.